here with Dr. Kursat Cagiltay, who is a professor in the Department of Computer Education and Instructional Technology at the Middle East Technical University in Ankara, Turkey. I've known Kursat, how long? Since 1997, 8? When did you go to IU?
1997.
1997. So we've known each other for a long time. Right now, Kursat is in Austin, Texas,
Yeah,
on a sabbatical, on a research assignment. What is it? It's a sabbatical. What would you
yeah.
say?
Now I'm a Longhorn.
You're a Longhorn for several months now. That's excellent. So Kursat's been gracious enough to talk about one of his research topics that he's involved with and has been in a while. And I I read about it in the Handbook of Research on Educational Communications and Technology, and the chapter was on smart toy-based learning. So that's what this is going to be about. Hey, Kursat, if you don't mind, before we start with the first question, talk about some of the things that you do at Middle East Technical University. What some of the courses you teach and some of the centers that you're involved with, if you don't mind.
Yeah. Actually, thanks for giving me this opportunity. It's really nice to share our experiences with the community. At the Middle East Technical University, as you said, I'm with the Computer Education and Instructional Technology Department. What I'm doing, mainly my research is focusing on technology enhanced learning. And I teach instructional design, multimedia design, and also on the graduate level, foundations of instructional technology. Human-computer interaction, it's also one of my courses that I've been teaching in the last 12, 13 years. So my research is also shaped around those topics: technology enhanced learning and human computer interaction. I'm also affiliated with the School of Informatics, Information Science, Game Technologies, Cognitive Science, and Neuroscience, Neurotechnology departments. I give thesis, master thesis, or Ph.D. Dissertations on those departments. Uh, what I'm trying to do is actually helping people to learn better. In the past, my research was mainly focused on adults, K-12 settings, but in recent years, in the last 5 years, I have been focusing on a different group. I think instructional technologists have not touched those areas. One of them is preschool children. The second group is special education area, especially mentally handicapped or mentally disabled children. So I try to use technology to help or to support those target groups, which I'm going to talk more about these issues.
Excellent, thank you. Yeah, well, that was a good segue into what we're going to talk about in your current focus. So, how did you get interested in? I'm just curious. How did your focus shift to preschool and special education? How did you arrive at that?
Yeah, actually, it goes to my IU days.
Hmm.
When I was at the Indiana University, I was, my kid, Bengisu, she was attending a kindergarten. It was a co-op kindergarten. So every week, actually, we also had to work in this kindergarten. We were running the kindergarten, so we should work about 6 to 8 hours a week. So I had a chance to observe, to this environment, kids. I had to play with them, I had to clean them, I had to feed them. Not only my kids, I also observed other kids, how they interact. And so at that time, my observation was about those toys. They like. Yes, I know. From my daughter. She likes to play, etc. But in a kindergarten environment, that was also more interesting. And I was thinking that why instructional technologists also deal with this target group, which would be nice. And also, I mean, if you look at from cognitive science perspective, I mean, we learn things with our senses, with eyes. We also use auditory channels, but we also have other senses. I mean, like touching. Unfortunately, when we are interacting with the computer, mainly we use visual input and also auditory input, and we don't use our other senses much. I mean, like touching. So while I'm thinking about this, I mean, as I said, about 5-6 years ago, I was started to interested in tangible interfaces, tangible objects. I mean, why can't we use, I mean, real objects, and how can we use those real objects or integrate those real objects with the computers? And so then at that time, I offered a course, a graduate level course about technology enhanced learning, and we try to develop some ideas. I mean, what can we do related with this topic? So toys was one of the most important issue. We had other ideas, we had other stuff, but we said, I mean, since kids like toys, and if we somehow, I mean, if we integrate toys and the computers together, then we could do something interesting. So we brainstormed on this. There are also technical problems, technical issues, because it's not just the software, also there is a hardware component. By the way, I mean, I also had some one degree from electronics. So I have some basic knowledge about electronics. So that also helped me what we can do and what we cannot do. And the other important thing is the technology that we have to produce has to be very cheap. And another thing which I would like to share with you is a cartoon. Here you see a cartoon over here. In most of my talks, I mean, I share this cartoon. Here, as you see in this cartoon, technology is running quickly, and education is trying to catch it, and barely. I mean, it's just following, and so wherever the technology goes, we educators, we try to follow it. So here, but in our case, the idea was not following the technology. Actually, technology and education has to go hand in hand, and we educators, actually, we have to create something for education by the help of technology, of course. So as in this cartoon, I mean, we first started with a problem, and this is directly related with with education, especially kids, preschool, kindergarten kids. And then we try to find out the appropriate technologies, suitable technologies. Then we come up with the smart toys or interactive toys idea. So we have been working on this one for the last 5 years. We developed some prototypes. Let me show you one screen, one photo. And our first prototypes were designed and developed for kindergarten kids. So here you see a photo that was taken in a kindergarten. We developed some animals, stuffed animals, so kids can touch those animals, and each animal actually has a kind of a chip inside. And so they use those toys to make it a part of a story. So the first prototype was about how we can use smart toys to help kids to improve their vocabulary abilities. And so, I mean, we have several tablet applications or PC applications on storytelling, but those are, I mean, the things are just on the screen. I mean, kids can only see two-dimensional, in some cases three-dimensional objects, but as I said at the beginning, they don't use their senses, I mean, touch senses, which is one of the most important ones, I think. But here they can touch it, they can change the orientation, they can look at it from different angles, etc. So we published a couple papers on pretty good journals. Our results also were very promising. I mean, kids who work on this kind of toys, they develop more, I mean, rich stories compared to our regular group. I mean, those kids who they also played with the same stories, but on the paper or also just on the computer. And so this encouraged us. And at the same time, we wrote our chapter in the handbook about smart toy based learning. And then actually I met with one of my colleagues. Actually, he also got his Ph.D. from Indiana University Special Education Department. And while we are discussing, actually we realized that this kind of technologies can also be very helpful for special education kids. Especially mentally, if the kids have some mental problems, autistics or mentally handicapped kids. And so when I show our prototypes to our friend from special education department, he said this has a great potential in special education. And not only, I mean, supporting kids cognitively, also they will be helpful for teachers, because teacher burnout is a big problem in special education. Teachers have to do things again and again. And actually this area, special education area, is they apply behavioristic strategies heavily. So, I mean, you may teach regular kids, I mean, a concept or a procedure in 1 or 2 attempts, but if you are dealing with a special education kid, you have to do the same thing again and again, maybe, I mean, 10 times, 20 times, maybe even some 50 times. And those activities should not be limited with the school time. They also have to continue those during the break time, when they are home, during the summer break. So they have to repeat it again. So we said, I mean, this has a great potential. And also another good thing, if you make something for kindergarten kids, you can easily adapt those products to this group of students or kids. So we started to work on this project, and at the same time I also submit a research proposal, Turkish Scientific and Technical Council, something like a National Science Foundation of the US. And 3 years ago we got some funding from this institution, and so we didn't just limit our work on interactive toys or smart toys. We also decided to include our other innovative technologies like multi-touch tables, tablets, and also bodily interactive products, I mean educational products. But the toys, I mean, or interactive toys was one of the most important innovative part of the project. I shared a video. I think you are going to share
Yes.
that video on your website. We developed some kind of interactive toys to teach how to use, or what kind of clothes they have to use, depending on the seasons. Here, let me show you one picture from our projects. As you see, here there are some real objects. Actually, some of them are with me. Maybe I can also show you. Maybe that would be a better example, like this one. This is a kind of jacket that we use during the fall when the weather gets hot, or maybe some gloves here. So in each of those stuff, there's a small chip, and the good thing is actually kids also feel the fabric, because those are made with the actual fabric. If you have a glove, it is made with this one, or if you have a jacket, actually this fabric is made with the actual shorts fabric, or others are this one again. This is for winter time.
So Kursat, each one of those has an RFID chip in it. Is that what I remember from the video? So
yes,
and is
they
it
all have RFID chips.
so how does that work to make the concept of a smart toy? How does that make those clothing? Kind of walk us through what's done with the RFID chip and how that makes it a smart toy.
Yeah, actually there's an RFID reader over here. So we attach this one to the USB port.
Mm-hmm.
And to make it more meaningful, we also prepared a kind of hand thing. So there's a software. In the software, it says, put for example, gloves on my hand. So the kid looks at here, picks the right object or the wrong object, and puts the object on the hand over here. So this hardware, this RFID reader, detects the RFID chip, and it sends the correct or the code of this RFID chip to the software, and software detects. It's a kind of a game actually. So when the software detects this one, and if the response is correct, the software gives the positive feedback. If the response is wrong, and then says you have to try it again. So all those feedback mechanisms actually was done based on the findings from the special education area. Feedback in that area is different than the feedback in regular kids. So we have some repetition cycles. Kids have to do some actions several times. So that's the main actually basic idea. We also did some experimental studies. We collected data about kids' progress. We also talked to their parents, how they feel, whether they can pick the right clothes for the right season. And right now we are working on the papers. We are going to publish our results. So the results are again very promising in terms of satisfaction, in terms of learning gains. Kids first, this environment motivates them, so they like to involve into the learning process. Also, our long-term findings show that they learn the stuff, and so also it is not a temporary learning, and because we repeated our tests several times, and then it looks like they keep this knowledge or this one for a long time. So as I said, I mean, it's promising. This is one example, actually, those things. Some of my other students are working on different topics too, like teaching animals, like teaching other objects, like cars or airplanes, vehicles. So mostly they are about life skills, daily life skills.
So and that's exactly the question I was going to ask was what are your students doing now beyond the clothes? So how do, for instance, the transportation or those objects, how does that work? Or do they have RF? Is it still using the RFID
Yeah.
with the
Yes.
hand and they're doing the same
Yes.
process?
Yeah. Yeah. One of my PhD students, I mean, she's doing that one. She bought, I mean, several small toys like cars, airplanes, or animals. So that's her dissertation. But right now, I mean, we are also moving to new technologies. Right now, tablets are getting more and more popular. So that's why maybe I think in the near future we are going to eliminate this RFID reader, and so that will be make more natural. So the object actually, whenever I take any object and when I touch or put it on the screen or the tablet, I will get the response from the screen directly. We are working on this one right now. So we did some small prototypes. It looks like it's working. So we will have a better technology.
So can you are you at a point where you can describe that technology, or do you not want to describe it?
No, I can describe. I mean, it's like touch screens. I mean, on the tablets, I mean, you put your 2 fingers or 3 fingers on the screen. So in this new technology, we are not going to add RFID chips.
Right.
Actually, we are going to add some stylus points on those objects.
Oh,
So, for example, if I put three three stylus items over here, the software is going to detect that, okay, this is a triangle with equal angles. So this means it's a slipper. Or if I make it different angles, and when I put this object onto the tablet screen, it's going to detect that this is this angle. So this is, for example, gloves or other objects. So that's the basic idea.
interesting. That's
Yeah.
neat. That's neat. So I mean I'm sure you started talking about preschool and then now you went into special ed. I'm sure you see that the research you're doing with the special ed can transfer over to the preschool as well. I mean, I'm
Yeah.
sure you would have some of the same findings about what the learning that would take place.
Yeah. Definitely. I mean, as I said, it's a two-way thing. First, let me actually share another picture with you here. On this picture, there's a kid from a special education center. He's playing with this smart toys. So those kids actually attend the special education center regularly. We also collaborated with the teacher, and same teacher used the same material for several weeks, and then she stopped for a while, and 2 3 weeks later she did another test with the kids. So we somehow we did some follow-up studies to understand whether this works or not. As you said, I mean, this technology can work on special education area or preschool area. Recently, I mean, about 2 months ago, one of my PhD students actually he finished his dissertation, and his main focus was on kindergartens. He also developed some those stuffed animals, stuffed materials actually, like he was using this technology to teach daily life skills like brushing or washing your hands, and also having the right eating habits, and also teaching some math concepts to kids. I mean, the geometric objects, colors, or other stuff. So that was also very successful dissertation. Yeah.
Oh, excellent. It's very fascinating stuff. So I always like to end the interviews by soliciting advice. So, what advice do you have for those instructional designers, teachers, or other educators? You can fill in the blank. For those who are interested in getting involved in smart toy based learning, what would you recommend?
Um, I mean, first recommendation is definitely putting more effort on those fields. I mean, as I said in my previous experience, I mean, we have been working with adults, use of technology in their education, or using technology in K-12 education. But I mean, as in the famous method and media debate, we make a lot of investment on technology in schools, but do we really get that much benefit? I mean, kids without the technology, they also learn stuff. And so, but there are some disadvantaged groups, and technology may play a big role, which is special education is one of them. So I think, I mean, as instructional technologists or educational technologists, we should focus more on this field too. This is relatively less touch area, and so, but it's also hard for us because it requires teamwork. I mean, I have my degree from instructional technology, but I don't know much about special education area. So I have to team up with some expert from this area, or early childhood education. Yes, I have some notions. I know something, but not in depth. So I had to also team up with some people from those areas. And technology also requires some investment, and so that's why I mean, instructional technologists have to also collaborate with the people, with engineers. I mean, there are really good engineers over there. They know what technology is and how or what we can do it, but they don't know how they are going to apply this into education or into a very special area. So this is a really good. This requires a really good teamwork. We have to work together, and it, and we should not just focus on the technology. We should also focus on the pedagogical aspects, and we need to apply good instructional strategies. And we should change our existing strategies. We have to explore new strategies by combining technology and pedagogy together. As I said, I mean, those tangible aspects, I mean, we should use those senses more and more. They are really very valuable. I mean, right now, the only touch thing is touching the mouse. Other than, I mean, or maybe screens, I'm doing some pinch or some gestures, but that's it. But we interact with our environment by touching. I mean, since we were born. This is really important, and especially with those new uh, technologies. There's a new wave like wearable technologies. I mean, it's going to be a part of technology is going to be a part of our daily life. We will not just stuck with the screen. So there's a new trend over here. There are new technologies, but technology, I mean, we should not like in the cartoon. I mean, we should not blindly follow the technology. We have to have some problems in our minds, and we have to have some knowledge on the technology side, and how this technology can solve this problem in a meaningful way. I mean, in our field, we have a lot of fads. We just follow some new shining stuff, but then after a while we forgot it. So we have to make this whole learning process meaningful by the help of technology. So that's my main suggestion for this for those who want to work on this area. It's challenging. I agree, but I mean, someone has to do it. If we don't do it as instructional technologists, someone is going to do it, and someone is going to do it wrong. So we have to be active, proactive in this field.
That was excellent. Thank you, Kursat. I appreciate you taking your time to share your experience with smart toy-based learning, how you got into it, and the research that you're doing. It's fascinating stuff. I will share links to a video that Kursat sent me about his students and some of the smart toys that they created, and I will also share links to some Kursat's research as well on my website. So again, thanks, Kursat, for your time.
Maybe before finishing,
sure.
Quickly mention about some of our other work on this field, other than this smart toys. Here you see another picture. On this picture, we are working on multi-touch tables. And this is also good technology especially for special education kids, because in our previous observations, we observed that those kids have some problems on using keyboards or mouse, but this interactive tables are very natural. They provide very naturalistic interaction. So multi-touch tables have great potential, especially on collaborative work. So that's one of the areas. But not everybody has a multi-touch table. So the technology can be transferable right now. I mean, you can run the same application on a tablet. I mean, you may run it on a multi-touch table, and at the same time, you can run it on a tablet. So in the second picture, actually you see the same student playing with the same application on a tablet with his friend. And that's also good for parents, because this means student is not only limited with the education at the school, in the special education school, he also continues education at home during the breaks, summer breaks, etc. So tablets, because of this, have a lot of potentials. Another project that we are running is it's about bodily interaction. Again, children and also special education kids, they use their bodily movements, and they can interact with the computers by using their bodily movements. So here in this project, we use Microsoft Kinect camera, and we develop some applications to teach some daily life skills. For example, one of them is how to make shopping. Special education kids have difficulties to go out and to supermarket and make shopping, and the schools, at least in Turkey, I mean, they take those kids to supermarkets. They teach how to make shopping, but this only happens a couple times in a year. Actually, with this product, with this software, we create a kind of virtual shopping environment, and kids have a shopping list in their hand, and they move around, and then they pick the right object or right or wrong object, so they can experience this shopping thing several times in a day, so they learn better. This is one of them. And our work is not only limited with the mental handicap kids. In my human computer interaction research group, we are also working with eye trackers. Here, there's another picture from one of our experiments. Low vision people, we are developing some software, some training software for low vision people. Some people have about 5% or 10% vision abilities. And in order to rehabilitate or to improve their vision abilities, we develop some games that are played with eyes. Just using their eyes, they can play a game. So we hope that this is going to improve their eye ability or vision abilities. And so I mean if your eyes have 5%, and if we increase it at about 2 degrees or 3 degrees, that would be fine. So we are working on this one too. And finally, we are also working on wearable technologies. As I said, since those toys are important, and we try to integrate those toys with some clothes. Here you see a prototype that we produced last year with some of my students. We teach those toys with some clothes. Here you see a prototype that we produced last year with some of my students. We teach internal organs of people, for example, heart, lung, liver. And so they attach those small toys to their bodies with some special hardware on their clothes. And so they learn the location of those, heart or lung or stomach, etc. So this is also a very exciting project for us. We are planning to do something more about this, how we can use wearables, especially in preschool environment and also in special education schools. So, the summary, those are the current stuff that we have been working.
That is some pretty cool stuff. Excellent. I look forward to seeing where you go with that and reading more about it, especially the wearables. That's I agree with you. That's going to become something that's even larger than it is now. So,
Yeah.
excellent. Thank you again, Kursat, for sharing that and talking about smart toy-based learning and what you're doing with it. You're doing a ton of great things. So,
Okay.
I appreciate you sharing.
Thank you. I hope I can also collaborate with other researchers. If they want to work, collaborate with me and with my graduate students, we will be more than happy. Almost every stuff we developed are open source.
Mm-hmm.
We share our software. We will be happy to share what we have been doing, and hope we can help those who need those technologies. That would also make us happy. We are ready to share everything.
Excellent. I'll make sure that your contact information is on the website. So
Excellent.
excellent. Thank you again, Kursat.
Thank you. Thank you.